first of all, I just want to say a huge thank you to everyone who's attending the event today. It's been a great turnout, and it looks like we've got a truly global presence as well, which is perfect. My name is Sam Lowe, and I'm the Business Development Manager at Operational Solutions. And today we're going to focus on, my presentation is going to focus on how we can use geospatial tools, specifically in the planning stages of deploying a counter drone solution, and how we can kind of get rid of the operational headaches and increase productivity whilst doing that. So to give you an introduction to operational solutions, as I mentioned, we're going to focus on primarily counter drone solutions today. And within counter drone, OSL would sit as a systems integrator. So effectively, we have our own command and control system, which is live in multiple international airports. And effectively what that means is we bring in a multitude of different sensors into one graphical user interface, and provide that to our customers so they can get real situational awareness of what's going on within their airspace. If we were to take a step back away from counter drone, operational solutions, it sits within a few different verticals, including UTM, which is universal traffic management or unmanned traffic management, ground-based air defense, and throughout all of those we offer simulation, consultancy, and also training. And we offer that to both aerospace, defense, and security industries, where we work together to inform them about system integration and how it could be really useful for them. And then also to give them a little bit of industry insight of what's going on, primarily within counter drone. Actually, we'll discuss new sensors that are available, what's good, what's bad, working practices that work well. And we basically have those conversations backwards and forwards so we can really produce a meaningful output for the customer. As I mentioned, we've got our command and control suite and drone detection solutions live at multiple airports, and they include Heathrow, Gatwick, and Auckland. And we also have great relationships with Airways New Zealand and also the Ministry of Defence as well. It's not all about countering drones, and I think that's what's really important to know. It's about knowing what's within the airspace. So we're constantly working on developing plans to make sure that, yes, how do you protect your airspace, but also how can you implement drones within that airspace safely? So it could be, for example, with an airport, you would use a drone to do an inspection on the runway, or at a prison, it might be that drones do a surveillance sweep around the perimeter of the prison. As we all know, there's a ton of different use cases for drones, and it's making sure that we can integrate them within one kind of tool that monitors both the good drones and then also keeps an eye on the bad drones as well. So in terms of, I mentioned before that Operational Solutions is a system integrator. And it's important to break that down in terms of what we offer within counter drone. So yes, we have our own command and control solution, which is a piece of software. But what's important to note is the fact that Operational Solutions is totally hardware agnostic. So we don't make any of our own hardware. We're also commercially agnostic as well. So if a customer has a requirement, say if that's an airport, for example, we would make sure that we pick the best hardware, what's available globally, to be as part of that solution, rather than using a partner who we have the best ties with, for example. And what that means is the customer is getting a solution that works for them. And in terms of the solution itself, it continues to be upgraded and modular and scalable, and we can do that all with the offerings that we have. So yes, we've got the command and control software aspect of it with FACE, which is our fusion assessment and control engine. We also do all of that integration ourselves, so we do that in-house. So we integrate the different radars, the different cameras, the different radio frequency systems, all within our own C2. We also fuse all that data together as well. So obviously each sensor that's in the field will have a line of data that it's picking up. And we make sure that in the back end of FACE, so the engine side of it that the customer doesn't necessarily see, all of that data is merged together in an effective way, which means that the false alarm rate is as low as humanly possible. And then from there, there should be no requirement or little requirement for a specialist operator. And the airport can either manage it themselves or we can do it on their behalf. One thing that we do, which is quite important actually, is system benchmarking. And what that basically means is we have our own test and reference facility at our headquarters in the UK, where we have a multitude of different sensors, again, different radars, different types of cameras, different types of RF systems. And we test them against multiple flights a day to see what their characteristics are and how they operate within a real world environment. And from there, that allows us to start, when we're having the conversations with customers, it allows us to really understand kind of what sensors would be appropriate for them. And then that then leads into the system design side of it as well, which is what we're going to touch on today and where the pain points can sometimes be with that. So in terms of, so you'll notice this slide is actually titled The Threat. But what you'll see on the right-hand side is a load of images that actually show how great drones are. And we're great advocates of drones and their use cases. So on the left there, you can see a drone that is assisting a farmer in spraying crop. We've got a drone that is carrying a rather heavy payload. We have a racing drone as well, again, incredibly fun to fly. But the problem is you can always flip that coin. So although we've got a drone that may be helping out a farmer in spraying crop, who's to say that that actually couldn't be replaced with a nerve agent and flown over a crowd? We've then got a drone which carries a heavy payload, and we've seen that kind of throughout the UK in terms of delivering COVID supplies and tests to remote islands. Again, all used for good, but actually, who says you couldn't swap out that payload and attach the likes of an explosive? So all these things have a flip side, and it's not about being critical about the technology. As I mentioned, well, we're very open to drones and we use them within our day-to-day running of the business. But it's just about making sure that we understand the threat and we know what they're capable of, so we can really talk to our customers and ensure that they are aware of what that threat may be as well. Now, it's worth noting that actually we don't always necessarily see that the bad side of the drones here in, say, for example, Europe and the UK. But in battlefields, for example, in the likes of northern Iraq, Syria, Yemen, and even kind of current countries such as Saudi Arabia, there are drone attacks nearly every day, where they may either be used for spying, or they may be used for carrying explosives and then dropping those or detonating them in the air. Now, we don't see that side of it over here. What we tend to see is a civil side where they cause disruption. And we saw that back in 2018 with Gatwick Airport, where the airport had to close. And it amounted to ridiculous costs on the airport side and also their airlines. And the reason why we're in the picture is to make sure that actually we try and stop that from happening. And we need to make sure that we do that in an effective way that works alongside the customer, so they understand exactly what's been deployed and the reason why they're investing in that technology. So as with drones, counter-drone systems also have weaknesses. So they have a great side, which in this case would be that they can detect a multitude of different drones and keep your airspace safe. But on the other side, you have kind of the operational side, which can cause quite a lot of weakness, actually. So you may have kind of the standout things where a sensor may have weaknesses in itself, whether that be in coverage or performance or whatever it may be. You've also got the associated costs with such equipment and how that plays a game, because whenever we speak to a customer, they always want to cover themselves against the whole threat, so all types of drones, but that's incredibly costly. And then you've also got lack of knowledge as well, and that lack of knowledge can actually play in the planning side of the deployment. And this is what we're going to focus on today, is how poor initial planning of sensor locations can cause a real issue and how we can use tools to really combat that. So if you take, as an example, an airport, and we go to site and we do a site recce for the days that we could do that kind of pre-COVID, there may have been an obstruction on site, which you may have not even seen as being obstruction because it was so small. But actually, if you take that over a 5 or 10 kilometer radius, you're then actually open and vulnerable to quite a large distance. So what we need to do is make sure that that isn't the case, and actually doing a lot of remote site recce's and even doing them in person as well. It can be really hard to try and pick up on that and what those blind spots actually looks like and where they are. And then it also begs the question, But even if you do all that due diligence, how do you actually test the system against a drone trying to enter it and make sure that it is detected and it is classified, and the solution that you have provided the customer or the customer is paid for is actually working as you said it was going to work? Now, the only way you can really do that in a real world scenario is by taking all the equipment to site, setting it up, doing all the calibrations, making sure all the sensors are where they're meant to be. And then from there, flying a drone, and if it was an airport, it's going to be across the airfield, and seeing where those gaps in coverage may be. And then from there, you could start to then add additional sensors to say, right, well, we need a gap filler in here, we need a gap filler over there, to make sure that actually there are no gaps in capability. Now, that's obviously very costly to do because, one, you need to send you guys out there to do those tests. You need to send the hardware out there, and then you need to conduct the tests. So especially at an airport, when is that actually going to be able to, when are you actually going to be able to conduct those safely? So all of these things play in, and then obviously you've got cost that's going to be a factor. And normally that is then obviously then passed on to the customer, so it becomes even more of an expense rather than just paying for the solution itself. So this is where the relationship between operational solutions and Carmenta came into light. And what we wanted to do was bring in innovative technology into the counter drone market that wasn't focused around detection and classification, identification and tracking. We wanted to do it kind of pre all that, so the planning stages and what that actually looks like. So we used Carmenta's extensive background in geospatial tools and their knowledge, and our own knowledge and background in Counter-UAS to create a joint product called the Citing Tool. Now, you can see it on screen here, and we'll look into a little bit more depth in the next slide. But essentially, what the Citing Tool allows you to do is visualize dynamic information. In this point, it would be kind of these orange blocks that you can see on the screen, and they are sensor deployments on top of static data, which would be the map. And in this case, it's a 3D map. Now, what this actually allows us to do is give the user, so the customer, or whether it be even us as an integrator at the planning stage, a unique benefit of being able to see counter drone coverage of a sensor of choice within a 3D environment. So straight away you can start seeing how well that sensor is actually working on site without even getting there, which is something incredible really, and something that hasn't been done before. So prior to installing hardware, which obviously has costs associated with it, or even testing and flying a drone on site against the sensors, we can actually have a really good idea as to how that sensor, the specific sensor, is going to work, whether that is a radar, or whether it's a camera, or whether it's an effector. Now for us, what that allows for is it allows us to accelerate the process of planning and also deployment. So when we're writing bids for customers and we need to make sure that we're giving them full coverage of what they've asked for, we can make sure we're using the right sensors for that. And then it's also a cost driver as well. So it pushes the cost down on our side, and then also from the customer side as well, which is a huge benefit all around. So it helps everybody. Now the question still stands, well, how does that actually help, and how does that relate to the blind spots? So what we do is when we're setting up a sensor of choice within the software, we make sure that we put in all the characteristics that we're aware of when we've flown against it at our test and reference facility. And effectively what it allows us to do is plot different sensors onto a map. So you can see three here. So on the left-hand side, you can see part of one. In the middle, you can see a full effector deployment. On the right-hand side, you can see another. So you can start to see kind of the elevation and the coverage that you're going to get from that sensor. If we take the effector for an example, you'll actually see the area that you are getting protection from drones. Now the issue is that if you have a look down here on the left, you can actually see a breakout area where you don't have any coverage whatsoever, and that actually follows all the way through near to where the effector is actually deployed. So we'd expect the effector to be deployed here, and we've got no coverage from here all the way out, and it leaves a huge gap. So actually, if someone was to fly a drone, they could fly it all the way through, and bearing in mind you would probably have an asset just behind it that you were trying to protect, and without even knowing, just based on the characteristics and the data sets that you would have on the effector out of the box, it wouldn't protect the site as you would expect it to. And this is different for obviously every site. So we can load any airport or any prison or any location into this map, and start dropping these different sensors. And again, it could be an optical system, it could be a radar, it could be an effector as it shows in here, and we'll start to understand where the gaps in coverage are. And for us, that is so incredibly valuable, and also for the end user as well, to make sure that they can continue to know where their gaps in coverage are, where they may need to invest in more money, in more sensors, sorry, and where their costs need to go. And that's what the Citing Tool essentially allows us to do. There's much more to the Citing Tool, and you'll see that from Jonas in the demonstration after this. But from me, that's all, and I'll open the floor up to any questions. If there are any questions based on the Citing Tool itself, it may be best to wait until Jonas has done his demonstration, so he'll probably answer quite a lot of them there and then. But if not, feel free to drop me some questions, and my contact details are on that slide. I'm sure I need to take them away and ask internally.
Fantastic.